Okay, so the last topic we're going to look at is how we synthesize organic compounds from each other. So if you take a step back and think about the different types of compounds that we've been looking at, we looked at straight up hydrocarbons, all the way to a ester that is a combination of two different types of organic families. As we've moved through looking at our organic families, we've learned how to synthesize organic families from each other. Ultimately, most of these compounds go all the way back to an alkane or an alkene. And so when a substance like an ester is produced, it goes through a series of steps where one of the parts of the ester starts as an alkene or an alcohol, and it has to go through a number of different reactions until that ester is created. So when we are looking at a series of reactions to make an organic compound, so think about all of the different reactions we would have to go through if we started with an alkene and we wanted to make an ester. It's called multi-step synthesis pathways. Okay. All this is doing is tying in what we already know about how organic families are synthesized from each other. I have a couple hints for you. When you are doing a multi-step synthesis, often using a flow chart to help is a good thing to think about. Sometimes we can write out a general pathway as a strategy line first, and then write out the correct structures just to kind of get your thinking going there. So just like we do in the stoichiometry in our math, where we kind of plan out our equations first, same thing here. And often it's easier to work backwards from product to reactants. So if you're asked to show multi-step synthesis, there's three options that you can use to communicate all the reactions that are happening. One of them is a flowchart. One is a series of equations. And the third one is just using one line equation. I don't care which one you use. My suggestion is try them all once or decide the one you like the looks of the most and consistently use that way. Okay, so get comfortable with one of the three options and then always use that option. So the best way for me to show you these, we're going to do a couple examples. So in our first example, again, you're probably going to either listen to what I say and then hit pause and copy, or the other way around. But in our first example, this is a flowchart. And the question, it says, write out an equation to illustrate the synthesis of ethyl butanoate from an alkene and an alcohol. So what we know is that the end result of this is that we want ethyl butanoate, which we know is an ester. Okay, so that is what we want to finish with. This is where working backwards really helps, because you know from learning about esters that this ethyl butanoate has to come from an ethyl alcohol, an alcohol that's an eth, and a carboxylic acid that comes from butane. So you know that you are going to have to have an alcohol and a carboxylic acid to make the ester. If you separate out ethyl butanoate into the alcohol and the carboxylic acid based on what the name tells you, you know you have to have ethanol and you know you have to have butanoic acid. Now, I'm probably going to ask you for structures. So if you use the flowchart version, you're probably going to write the structures beside the names. Okay. So now that you know that you have an alcohol and a carboxylic acid, pick one side and finish it, and then do the other side. So in order to get an alcohol, you have learned in your reactions of compounds, organic compounds, that it is the hydrolysis of an alkene. So to get this ethanol, you have to have an ethene that reacts with water. So all you do is write that in, and then that side is finished. You have your alkene. Now you have to go over here to the carboxylic acid, and you have to show the steps on how you're going to get from an alcohol to a carboxylic acid. You know from our from our lessons, that a carboxylic acid is formed from an aldehyde. So this is pretty easy, because to get butanoic acid, it has to be oxidation of butanal. And then to get a butanal, you get an aldehyde from the oxidation of 1-butanol. So that's all this is all a multi-step synthesis is showing the series of reactions it takes to get a product from 2 starting points. Okay. The one thing I want to point out to you is that you need to show all the other things involved in the reaction. So if it requires water, you need to write that in here. If it requires the sulfuric acid, you need to write that in here. If it requires an oxidization agent, then you need to write that in. Okay, so hit pause, make sure you have this copied, and then we'll move on. The second way to show the multi-step synthesis is a series of equations. Now, this is a really nice way to organize it, but it's a little bit more work. I've done exactly the same example that we've done above. But what I have done is I have written out all of the reactions. So this is reaction 1. And then there's 2, 3, and 4. So I have written every reaction out on its own line. I have shown ethene plus water making ethanol with the structural diagrams, because I'm going to ask you to do that. And then I'm showing the 1-butanol oxidizing into the butanal. Then I'm showing the butanal oxidizing into the butanoic acid. And then I'm showing the butanoic acid plus the ethanol with that sulfuric acid catalyst. We know you need that. Making our ester ethyl butanoate plus water. Okay. So this is a little bit more work on paper, but it just depends on how you want to organize your thinking. I kind of prefer the flow chart for me. To me, this makes the most sense, but I'm a visual learner. It's totally going to be whatever your preference is. Okay. The third way is one long equation. I'm going to show you a different example. Okay. So, in the third way is a line structure diagrams to show the synthesis of pentyl ethanoate from ethene and an alcohol. So the first thing you have to do, again, working backwards, is kind of the way to approach this. You know you have pentyl ethanoate. So that is, again, that is an ester. And so based on the name, you know the pentyl is coming from an alcohol, and the ethane part has to come from a carboxylic acid, which over here is telling you have ethene. So you know that carboxylic acid has to start as an ethene, and the pentyl gets to start from an alcohol. The question will usually give you a little bit of a hint. So one series of a line equation is basically taking the second way and cramming it all together. So we are going to start from our alkene, and then, I'm going to work backwards. If you have a carboxylic acid, which you know you need for your ester, it has to come from an aldehyde. We know that already. The aldehyde has to come from an alcohol, and the alcohol has to come from an alkene. The problem tells you the alkene is an ethene. which works nice because you know you need an ethanoate part of your ester. So ethene plus water makes our alcohol, plus our oxidizing agent makes our aldehyde, plus another oxidizing agent makes our carboxylic acid right here. And then we know that carboxylic acid is going to react with this pentanol to make our pentyl ethanoate, which we see right here. And again, remember in esterification, it releases water, so you need to write that in here. All right, so hit pause and make sure you have that down. And then I'm going to suggest that and then we have our next example here. Example number 3, show the synthesis of 2-pentyl butanoate from pentene and butanol. Now, you have to think about where to place the double bond so the hydroxyl group is on carbon 2. Okay, because you have to be careful here because Markovnikov's rule will dictate where you can put your hydroxyl group based on where the hydrogens have to go. So I'm going to suggest you hit pause, give this a shot, and then unpause and check and see how well you did. All right, now that you've tried it, let's see what our solution looks like. Here it is. Okay, so here we go. We need 2-pentyl butanoate. So that means we're going to start with 1 pentene plus water is going to make 2 pentanol. And what that means is that, what this 2 means is that the pentyl is attached to the carboxylic acid on carbon number 2. So here's carbon 1 and here's carbon 2, and the oxygen is attached here. So again, this looks a lot like what we've seen before. We have our pentene making our alcohol. You have to put the hydroxyl group on carbon 2 here. And then we have the carboxylic acid coming from our aldehyde. And then we have our 2-pentyl butanoate here. Okay, so I'm going to post a couple for you to try for practice, and I know you will have 1 or 2 of these to do on your assignment, but just remember, all it's doing is putting together what you already know. You already know how to make different organic compounds from each other. Now you're just showing the series of reactions to get from 2 different substances to an ester. Okay, so that's it for our multi-step synthesis, and I hope you have a good day.